All right, so I'm trying to figure out how to change the angular velocity of this wheel, which I have rotating in this direction, which I'm representing by a vector which points away from me into the screen. And I can think about, well, if I wanted to speed it up, I'm going to need there to be an acceleration, an angular acceleration, again, in the same direction as the motion. So if the motion's this way, I need an angular acceleration that's in the same direction, very similar to what we have over here, which would mean that it needs to point this way. On the other hand, if I wanted to slow it down, I need to have an angular acceleration that points backwards. So that would be out of the screen at me. And sort of by analogy here, right, if I have an angular velocity that points this way, and I want its direction to change, then I'm going to need to act an angular acceleration that points perpendicular, which could be this way, could be this way, it could be up or down. Any of those would be perpendicular to the motion, to the angular velocity vector. So any of them would change the direction of the angular velocity. And you might think about what that would look like, right? Rather than speeding up or slowing down the object, that's going to cause the object to do something like this, right? That would change the direction of the angular velocity from out or into the screen to being a little bit angled and a little bit angled and a little bit angled. And so you might expect motion like that, or depending on exactly which perpendicular one you choose, right? It might end up going up or down or any of those, right? But it would change in a perpendicular way rather than just speeding up and speeding up and speeding up, or slowing down and slowing down and slowing down. This fundamentally is the motion called precession, when instead of speeding up or slowing down angularly, you get a change in the direction of the angular velocity. And often what you'll think about is not just velocity, but momentum, and therefore not just angular velocity, but angular momentum, right? So if I have a bunch of angular velocity this way, pointing that way, I also have a bunch of angular momentum pointing that way. And then I could change that angular momentum by having an appropriate angular acceleration, which again, an analogy here would mean that I would need the direction of the net torque to point in just the way that these vectors do if I want to speed up, slow down, or change the direction of the angular momentum.